Welcome to Unit 2, Part 2 on operating system design. In this unit, we're going to talk about operating system structure. So we're going to talk about operating system structure, which is how the services and components of an operating system are organized in the software. Then we'll talk about virtual machines and some more about types of computer systems and system calls. So here's an overview of operating system services. As you can see, there's the services. If you remember, you want to be able to execute programs, perform I/O operations, communication, file systems, allocate resources, do accounting, protection and security, detect errors, and a way to interface with the system. And all this should be managed by the operating system. So the way that these services work together is what is the operating. An operating system is a very complex software. So in order to, when you're developing this complex software, you can design the ways in which the services work together. The early designs were monolithic or simple structure, which means there was no structure at all. But then there were ideas to organize the interfaces between the services, and the first way to do this was the layered approach. Then there was the microkernel, the modular, and many modern systems today use a hybrid, which is a combination of these different types of structures. So first we have a layered design. A layered design means that you have clearly defined interfaces between the services, and the services are on a particular layer. So if layer 0 is the hardware and layer N is the applications and the interface with the operating system, then all of the services of the operating system are placed on different layers. So a layer will use all of the services of what is below it, and then it will provide services to what is above it. But the problem then lies in, what if a layer needs to use a service in a layer? What if a service needs a service that's in a layer above it? And if it wasn't clearly laid out, then you would have problems, because in a strict hierarchical layer software development structure, you can only use the layers below you. But there are some benefits to using a layered design. You have clearly defined interfaces between the services, and you can it's good for development purposes, because if you know if a layer is working, and then you go to get the next layer above it, you start working on the next layer above it, and you start to run into problems, then you know that the problems are going to be in the new layer that you are making. So there are benefits and detriments to using a layered structure, which you can read more about in the notes that are posted on Blackboard along with this unit. So like I said before, the next design idea was a microkernel, and with this idea, it was to move most of the services out into the user space, run all those services as user applications, and have a very, very small kernel. So when the system goes to load up, all you have to load up is this very small kernel, which is basically a communication, a little bit of scheduling and memory management, and move all of the other services of the operating system outside of kernel space. So the benefit to that is it's easier to port to different architectures, it's easy to extend, you can make new services that are user applications, and you just have to bind them have them work with the microkernel. It's more reliable, it's flexible, so there's a lot of benefits to using this microkernel. The detriment comes in the overhead. Now, because the microkernel needs to have control of all of the applications on the system, it also has to have control of all the kernel services that are run as user applications on the system. So there's a ton of system calls going on, and a ton of system calls for communication. So that is not a benefit of this, because it slows down the process if you have to constantly have the operating system get involved when any of the services need to work together. So the modular, and the modular is the latest, and it uses the object-oriented approach. Has a small kernel. The components, once they're loaded in, they can work together. So it's similar to a layered in that there's interfaces between the services. It's similar to the microkernel in that it has a very small kernel and more flexible and all of that. So this is clearly the best way for implementation. However, if you notice, when you get to the point where you are in modular, you have all of these services that are working together and interfacing with each other without kernel involvement, then you're actually almost coming right back around to a monolithic structure where you just have processes that are running on your system and not in any kind of strict hierarchy. So most systems do use a hybrid structure where they would have some type of layered structure with certain functions and services on certain layers, and maybe a microkernel in there or just modules. And there's always new ideas coming along, but this is just the basic understanding of the different ways you can structure the services in this software of the operating system. So take a look at your case study, and on your case study, this will be your first case study assignment, will be for you to locate and find the figure and look at it of your operating system. So also take a look in the notes at the modular versus layered comparison. The next thing I want to talk about is a virtual machine, and a virtual machine allows one hardware to run different types of systems. Now, this has been around a very long time. I know now you can run Windows on an Apple computer and stuff like that, but the idea came about a long time ago for isolating different systems from each other on one hardware for testing. So it was developed a long time ago, this virtual machine, and it usually did not have a host operating system. It just had a host software, which was called a virtual machine monitor or virtual machine manager. And you could run different, completely isolate each system from each other and run different processes all on one hardware, or run different operating systems on the same hardware, and one could crash and it wouldn't affect the other ones. So you're going to have a question in your homework about different types of computer systems, and the different type of computer system does affect the operating system, the role of the operating system, the structure and the design and the plan for the operating system. So one thing I do want to point out here that there are interactive systems and real-time systems, which means it needs to perform in real time, but there are hard real-time systems in which someone could die if it doesn't perform in real time. So that concludes this week's video. Please take a look at the notes, and thank you very much, and you'll hear from me again soon.